Thank you. Hi, everybody, and thanks for coming. Hope you all enjoy it. About myself, my name is Alexander Chumakin. I worked in quite a few big companies like Ingenico, Worldline previously, in Camster, Philips, now at JetBrains in one of our Amsterdam offices. And I worked as a freelancer in outsourced companies, so I have quite various experience in different products. And I worked with probably all the possible test automation areas, including performance tests. And I started it like 8+ years ago, and comparing to other test automation areas, I see a high demand in this area. It's really growing rapidly. And I want to talk about this topic today because of two main reasons. The first one is this annoying loading icon. Nobody likes it. You actually see it everywhere in your favorite websites, in mobile apps, even in terminals. And this is something that can lead our end users to think about going to competitors, because nowadays people don't like to wait. They need exact great performance all the time, even in high peaks, in peak hours of your app. So this is where you need, or you should think about performance testing of your product to make sure it will handle the desired amount of users with the appropriate responses. It's still annoying, right? So getting rid of this by improving performance of your app enough will lead you to happy customers that will probably cause a happy manager and a good financial bonus for you and your team. And the second reason why I want to talk about this, because quite recently in my previous project, I discovered a set of fantastic tools that can help you to build it in a modern, effective way. So today we'll learn how to get an instance of your production-like Kubernetes cluster and run locally in your laptop, how to implement tests in K6 tool and run them right inside the cluster using another tool, Testkube. So before we switch to testing part, want to ask how many of you have worked with the Kubernetes? Know it good enough? Cool. So I'll quickly, for others and for online audience, go through the explanation. So in normal way, when you develop an app, you containerize it in a little box called Docker container, run it locally. But in more real case, you have a picture like this. When you have a network of a few containers where your app is running, you have a balancer that spreads the load between them, and you have some controller like Nginx, for example, that can help you to get inside your network. And then, of course, you need to add security layer, you need to have some exceptions and so on. So your coding becomes more and more in infrastructure part. That's why in 2015, we had a cool tool called Kubernetes that actually provides you a set of many different resources and group of resources that helps you to configure infrastructure in a very effective way. So we still have the apps running in containers, but now it's inside pods. You replicate it with a special resource replica set. You have a network level with the policies, gateway, ingress controllers that can help you to get inside the cluster, services that actually goes to pods. We have a data layer, security. We have a different secrets and configuration, config maps, and cluster can be installed in different machines, racks, whatever. So you have a nodes that actually help to work with the hardware level. So all this stuff is built to nicely handle network security and other important stuff just for your apps. It's very hard to draw a diagram because there are a lot of lines and so on, but you got the main idea. And I have implemented a little Java app for this demo that we will test today. You can scan this QR code or get a link later. And together with Java, I used a library called Quarkus. It's not so widely known as, for example, Spring, but I really like it a lot after working with Spring and Hibernate for quite a lot. And the main reason why is because it has a native integration with a Docker and Kubernetes. So it actually generates everything for you, all the Docker files, all the specifications. And when I need to run this Kubernetes cluster in my laptop using technology called Minikube, I just add a little dependency in my Java POM file in my framework, and it generates the specification. So I like this automatic generation, I like the automation of the job, and not just test automation, but the automation kind of infrastructure. So when you apply this configuration to your local host, you will see an infrastructure like this. When I have my app running inside the pod, it can talk to my database via service. It persists some data in my host. I have an ingress controller with customized name in config file that actually talks to my application, and it's all in one single node. Minikube is a great tool when you don't need to test multiple nodes, when you just need to functionally test your app running in Kubernetes cluster. You can spin it up locally with Minikube. It's one of the simplest tools, and it's quite easy to configure and start with. Regarding Java part, it's quite a complex language, I know, but it's still kind of market standards for microservices. And to make our life easier, there are a lot of talks about AI today, probably tomorrow. So I generated some code using ChatGPT. I just asked for a specification. I said there are some errors when I try to compile. I said to make some decorators. Then I asked to generate unit tests for me. I just added some dependencies, copied tests. Then I realized there is no mock. I said use database mock. So all this stuff I just get locally, created a new project, polished it, and pushed to GitHub. And it actually works pretty cool. So even with the languages like Java currently, you can use AI to simplify your life. It's maybe not perfect, but I polished it good enough. So what this app can do, it can create a payment with post request and some data. It can get a payment by its ID. It can get a list of payments from database and delete the payment. That's it. And I think it's quite enough for the demo part. So let's see how it looks when I run it locally. I tested it with a curl command, and the host is specified in my ingress controller. So here in the first request, I create a payment with the amount, currency, and name. It generated a response with ID. By this ID, I can get a list of payments or details of this payment by its ID, and I can delete this payment by ID. That's it. So we are done with the target application. Now we can actually start testing. And for testing part, there is a fantastic tool called K6. I just discovered it a year ago. And when I went to their official website, to documentation, I saw a pretty simple example, and it's all pure JavaScript. I was like, OK, I'll give it a try. And it's as easy as they explain, in my opinion. You just create a function in JavaScript. There are all required libraries to work with HTTP, TCP, to mock results. There is a great assertion library as well. And it's very easy to run this test. You don't need to install any extra dependencies or build node project. You either install a CLI or you run it from a Docker container. That's pretty cool. And to prove it's really easy, I will again ask ChatGPT to generate tests. So I create a specification, an example of curl commands, and say, please create test for me. I just copied the script that it generated. I create a JavaScript file. I pasted it here. It's not the first try, to be honest, but I went there quite fast. Just ran it, and, well, it worked. I see the amount of users is growing. It limits it with 20 seconds. I have some metrics. We'll get back to it later. I mean, it's cool. It's really different from other performance testing tools. It's really, really simple. I have a few stories of my friends that went to me and asked for a recommendation about what to start with. They want to integrate some performance tests in their company. And I said, well, I have quite a good experience with K6. And their response was, in a few hours, like, hey, it works. It's easy, it's really simple to install, it's really simple to run, and it's simple to read, and it's really effective. And we don't need a strong laptop for this. I'll get back to it later as well. To compare it with something else, I have a very good experience with a Gmeter. So that's why I will try to generate it with Gmeter. But recently they implemented Java DSL, so we can finally write a performance test for Gmeter in Java, and it will generate this JMX kind of XML files for Gmeter. I copied the request that worked previously, but asked to generate it with a Java DSL, and hope something will work. So it generated some JavaScript and some properties files. I will create these property files here. Already some simplification, it's Java, and you need to install Java locally, right? You need to set all the environment variables. I will copy this JavaScript that it generated. Officially it's allowed to run single Java file, never works. There is a proof. Yeah, it says can't. I Googled, I asked ChatGPT why it doesn't work. I installed Gmeter. I sent a pass, didn't work. I cloned their official example and moved this Java file inside to run it with Maven command. Didn't work. I said, it doesn't work, there is an error. I said, okay, you need this dependency. I said, okay, dependency set. Let's configure dependencies, okay. There is some. It generated with GNU3, whatever. So I got this Apache Gmeter dependency, and I will insert it here and try to rerun to see whether it works. What do you think it will? It will not, of course. It's Java. One more try, another run, another error, something new. I asked again, it said, yeah, it's a wrong dependency. We need a set of dependencies. Of course, obviously. Why didn't you say it the first try? I'll go edit POM XML again, make sure it's exactly the same one so I don't reuse the previous example. Yeah, it's the same dependency, so I'll clean up the old one. Quickly try to run again. Last one, I promise. Just install dependencies, forget about this. Of course, it didn't work. To be honest, I tried for another hour asking about trying to fix your code. It didn't work. I mean, you can, of course, create everything from scratch, and it will work. You can configure everything yourself. But the first point I want to mention about comparison, K6 and Gmeter, is language. Even if you create your app or you develop your ecosystem in Java or JVM language, it might be a good idea to use different technology and programming language for testing part. Why? Is because it's fast, it's simple, and you can really start fast. And if you get your new team members, it's much easier to transfer JavaScript performance tests than this project with a lot of configurations in Java, blah, 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 a lot of stuff. By the way, the reason why I compare it just with Gmeter today is because it's kind of market standard. A lot of people work with Gmeter, and finally, not only Gatling, but Gmeter has a nice way to write tests in a normal programming languages, not in this GUI tool. The second important reasons, as you saw, no external dependencies. In Gmeter, it's quite hard. Any JVM language, you need to install Java, Maven, you need to configure all the environment variables. You need to be environment specific, because in some environments, some versions of Maven and Java won't be compatible, and so on. And for K6, you don't need any. You can even run it from a Docker container. Very cool one is resource utilization. As I said, even my friends with not this M2 Mac laptops said, well, I can run quite a high amount of parallel users. That's pretty cool. And they talked about thousands per second. And the reason is K6 is written in Go programming language, and vice Java, it can handle much more parallel threads, obviously. Who worked with the Gmeter or Gatling knows that it's quite hard to run more than 1,000 requests per second possible, but yeah, very environment specific and not much more. But these tests and this microservice locally, I was able to run about 20 times more parallel threads at all in my K6 without any extra optimizations with Gmeter. And it's really cool because we don't need to handle more expensive machines that will run our tests. And last but not least is memory management, because in JVM it's quite tricky. Even if you pause this JVM arcs, it's not always working as you expect. And the K6 use native load-generated memory that helps you to utilize as much resources as you need, but not more than is required for tests. Means you will only allocate as much resources as you need for tests at this moment, but not for the whole run. I polished the script that ChatGPT generated. There is another GitHub repo, and I personally am a big fan of splitting code and tests to different Git repositories. The lovers of monorepos will hate me. It's all right. JetBrains as well, by the way. So you can scan the code or get later. Instead of going through tests, I will just show how run looks. So we see the amount of users is slowly growing. Then we keep the high amount for some time, and amount will go down in rundown period. It's very easy to set up it with the built-in configuration. You see the result of custom assertions. If there are any errors, you will see it right here. And there is quite a lot of useful information right here. Like we see how many requests were done, what's the load. It's average 124 requests per second. Average request duration is 20 milliseconds, max is almost 1 second. So from this metrics, you can already try to analyze your app. So what's wrong? Why some metrics are not good as expected? You can increase the load and so on. But I ran this test locally, and it's not the best way to run tests, right? So when we implement tests, the next step is to run it from some CI system. So we usually have our app deployed to some cluster, test, production, whatever, and we have it running somewhere, and we have completely different system for CI. Sometimes it's a cloud, it can be deployed locally, but in the most of cases, it's different network. So via network, you connect your test to your app. And for performance tests, for many tests, but performance especially, there are a number of very critical problems in this default approach. The first one is lag. So internet connection might cause some unpredictable results. You have a response of 1 second. What does it mean? Is it app working slow, or is it 90% you spent on a network latency? Hard to analyze. You need to add some more tools to analyze it. Connections might be broken, especially if you run it for hours. You might see some timeouts or whatever that are not really relevant. It's really hard to analyze the final results that were run for hours just because of some internet connection were broken a few times. And even worse, in some companies, there is a wall. So sometimes it's not possible to connect from outside of the cluster to some components that you want to test, actually. So your developers will need to create some additional proxy or some job, or will deploy some agent inside the clusters and get through all these problems again. And for many tests, but again, especially for performance tests, there is a great tool that can help you to avoid these problems called Testkube. And with Testkube, you install this little CI system right inside the cluster, but for every cluster. So if you're testing pre-production cluster for performance, you install Testkube inside, and you run tests from there. We'll get back to details later. Other than network latency, important part to mention is the price, because when we talk about CI, we always talk about money. And I just used the official GitHub Actions calculator. I know the market standard is probably GitLab, but it's times more expensive. So for 10 users, 50 jobs per day running for 1 hour. In the most default Ubuntu Linux, we'll have around 1,000 per month. In real cases, it's much, much more. In big companies, it's about millions. So this infrastructure for running your stuff costs money. And when you extend it for your tests, especially for performance tests that require high machines with high availability in different availability zones and so on, this is very, very expensive. Even if we look at Testkube Cloud solution, there is one free plan that is quite cool, or just 200 per month if you use different environments, up to 3, and custom plans, of course. But today we'll talk about fully free open source solution. And I can't explain Testkube better than their official website. It's a very easy way to run your tests inside the cluster, any kind of tests. They even provide runners for some corporative tests like RunnerX and others. Yeah, it's very easy to install this tool into your cluster. I will show how later. And when you need to connect your tests for this kind of CI system, they provide a dashboard. So once you deploy the Testkube inside your cluster, you'll have a link for this dashboard, and you go there, and just in a few clicks, you connect your tests via Git repo or any other ways. There is already existing executor for K6 and other tests as well, and you just connect the tests for this source, and that's it. You can start running. It's much easier than GitHub Actions or GitLab CI/CD. It's really something as easy as K6, so altogether it's kind of, yeah, win-win. When I apply Testkube infrastructure into my cluster, I will have a few ingress controllers for dashboard and API. They will talk to pods, and pod can talk directly to payment service. So I will work with my service inside the same node. And the cool feature is Testkube provides an installation of the stuff via Helm chart that installs multiple Kubernetes components in one go with one configuration file. So it's very clever to develop some infrastructure components as a Helm chart because you manage everything in one configuration, one go. And how it actually looks. So you have a nice dashboard where you can modify some default parameters like amount of target users, for example. You can run your tests, and you see exactly the same output as I saw locally. So now everybody has the access to the cluster and to this link and start running tests with different users so we can prepare the job, all the infrastructure job and gifts to somebody so people can start running, analyzing. But the problem here is this matrix, right? It's really hard to read. It's very easy to lose something. And for people who work with data, there is some visualization required because not only looking at the results, but comparing the results with previous runs, it's really hard. And what I want as a visualization tool is Grafana. I want to go to this part, and Grafana is a favorite choice here for sure because of the main reasons. The main reason Grafana owns K6. So K6 was acquired by Grafana around 2 years ago, and they have a native integration. So all you need to do is build a mid layer with some database. In my case, it will be InfluxDB. They have a documentation with all the instructions how you can set up different mid layers. So with K6, I will send results to InfluxDB, and Grafana will use it as a source and will show it for us. So to summarize what I said before, I will run all the installation from scratch. I see there are no Docker containers. I configured a few hosts to be able to go to these nice hosts. I will start my app. I will start a Helm chart that will install Testkube, and I will import Grafana dashboard because there is already existing template. So just by running commands locally, I can go to TestKube. I can check there are some predefined configurations that I saved as resources. I can run it. I can go here and see that new requests are coming. And once they're coming, I can actually go to Grafana, and instead of looking to TestKube metrics, I can see the nice graphs in Grafana dashboard. So I'll apply a filter for last few minutes, and I see requests are coming. So instead of looking to this, now you can look at that. And for me, it's much easier. And it's template, so you can adjust it as you wish. But default template looks pretty cool for me. It's almost good. It's almost good. What is missing, you might notice I ran this test manually. So every time I clicked run now, it's not real CI. With CI, I have an important requirement for myself and for the companies I work for. CI means tests should be triggered, right? So whether you have tests in the same repo as dev code or different repo, they should be triggered. You should know when and how to trigger tests automatically because of many reasons. People might forget to run tests, don't care, don't have an access, whatever. Just a bad day. Or you have quite a stable test and they always pass, so developers say, no reason to run it, they will pass. Don't want to spend time, or I need to apply a quick fix, go to production right now. So tests should be triggered. It's not always should be a blocker for further development, but if there is something wrong, you should find it with your tests in the earliest stage. It's my opinion. And here in TestKube, they provide another fantastic tool called triggers. And right in UI, you can say when some event is happening. For me, it's deployment by name, payment demo Quarkus app is created, then do what? Do run test by name, payments test. And just because TestKube is running inside the same cluster as app, it can listen to Kubernetes events. So I prepared a little shell script that will rebuild and redeploy my app inside my Minikube cluster. And I see when it's done, I will quickly inspect that, it's running for a few seconds, so new version is applied. I see the test is automatically triggered. And if I have Grafana dashboard open it with some filter like last 5 minutes, 30 minutes, somewhere in my office, I will see new requests are coming. So once somebody deploys a new version, if it's done silently, you will see that it's actually started to test. So you can have a monitor in your office and always have open Grafana dashboard for pre-prod, for example, or wherever you run your tests. And you see when tests started, if there is something wrong, like too many errors, too high response time, or whatever is unpredictable, you can see it right away. TestKube provides many other nice solutions, like you can send an overview in Slack or by email, or it can only do it on failures and so on. But even with having this quite a simple integration, you can already see some results and catch some problems. And regarding problems, you might wonder, can this test actually find issues? Yes, they can. I especially created my app in the way so it will fail with some amount of users. So I usually slowly increase the amount of users to see how my app reacts. I will increase it 4 times. I will see there are no errors, everything is good and green. I will increase it 10 times from the initial load. Remember, it's still all running in my local laptop, not this one, but home one, not that strong. And with some amount of users, you will start to have failures. So here I have some 500 from local debugs, and I see duplicate violation constraint because my key was integer. I changed it a bit. I rerun, I reapply my change, redeploy, tests are triggered automatically, and with the same amount of users, with the 50 in a high load, I will see that it all works now, but the threshold is breached because response time is high because I fixed it not in the best way. So all I did is just changed integer to UID, and it's quite unique. Just apply it to the schema, and I will try to break it again with 100. I'll run it. I'll see that everything is good, except of request duration. It's still too high. I will then increase it again to try to break this code. So other than performance issues, we can find some issues in a code that are usually only catched in production when a lot of users come on peak hours. Still looks good, but request duration is growing again, obviously. And I will increase it one more time. 100 more than initial load. So it's 500 users, but every virtual user makes like around 10 transactions per second, and I have around 2% of failures, and I see there is a timeout. So there should be another fix. I have it in other branch that just uses another reactive library that handles multiple requests better. So with the performance tests, we usually can find non-functional bugs, but bugs that can be only catched in our production system for the end users. So to make sure you don't face with this situation, performance tests are good stuff to start with. I have all the examples in my GitHub repos. Feel free to get it. In my Twitter, I posted an article in a Medium, so you can read it again. I have all the links to all the documentation. Feel free to read it carefully. And if you don't have questions now, I'll be happy to answer them on Twitter later. Thank you very much for your attention, and looking for questions. Any questions?
Thanks a lot, Alexander. I think we have some time, yeah? Yes, please.
Hey, thanks a lot for the great talk. Do you have any recommendations regarding settings? So you showed with like ChatGPT can generate enough data for tests. Are there situations when something needs to be configured?
Well, it's a good question. I mean, their official documentation is usually enough to start with. And before you start creating tests, you probably have some Postman collections or some examples of curl commands, Insomnia, whatever. So it's very easy to automatically convert it to JavaScript. Even in Postman, there is a button, convert to JavaScript. Paste there, just use their official libraries and try to reuse the existing commands for performance tests. Because performance tests that are not functional, you don't need to create complex models for requests to parse responses, check all the response data. You just need to make sure it works. Just ID exists, status code okay. It was just an example that it's quite easy to work with, but it doesn't mean you always need to use ChatGPT for writing your code. But consider this. Any other questions? Sure.
Yeah, thanks a lot for talk. Just wondering, as I understood, like the tools are great, but I have to go to the Testkube, configure something. After that, I have to go to Grafana, check metrics. Are there any plans in JetBrains, probably, to have something configured via my IDE? So I can go just one place, I can add everything here, run it locally, and make sure it works.
It's a good one. I don't know about such plans anywhere at JetBrains including. The problem with local running and trying to connect this kind of cloud system into IDE is always backward compatibility, many platforms and so on. That's why the most of cloud solutions come as HTML, so you can open it in your browser, and not everybody have the same IDEs. So another set of plugins will come. I think Testkube is a great alternative for CIs, and we should not mix Testkube with K6. I just showed an example how you can run it inside the cluster. For performance tests, you should always run tests as close to your cluster as possible, ideally inside the cluster. And Testkube is one of the options because it's free and quite easy to install, and you can manage it as infrastructure as a code. That's pretty cool. And you don't need to know very specific knowledge about particular CI system like GitHub Actions, TeamCity, GitLab, CI/CD, and so on. So it's just an example of how you can integrate different systems. I'm sure you can do it with JMeter and GitLab and some other tool for visualization. But yeah, you can have some insights how to integrate it all together. And no, I don't know any real tools that can make it all securely. Because if you use some existing cloud solution, I know there is a Ukrainian company, Testomat, that can run your tests in their cloud against your servers. But because of security, because of this network breach, it might also be not the best solution. So there is something you should install into the cluster.
Yeah, makes sense. Thanks.
Sure. There.
Thanks. Question about Testkube. You showed as example that you install it probably locally, probably on cloud, not matter, did some changes manually, run tests again, saw some results. Is it good to use it if I need performance as a part of my CI, which means in every change of my product, automatically should be everything started and somewhere it should be triggered by Git, and after that, my Git should tell me that, yeah, test passed and you can merge.
Yeah, there are two ways how you can run any tests in Testkube, main ways. First one is this listening of events in Kubernetes, as I showed, like some image is changed. Like means in your Kubernetes infrastructure code, somebody deployed an app that should be tested for performance. Another one is Testkube has a native integration with the most of CIs. And from CI, like GitLab CI, you can trigger jobs in Testkube. And they are fully synchronized, so once it's finished, it will get the results back to CI in development pipeline. So if you want to make it this chain of a pipeline as a little build, you can integrate it with a native integration. Yeah, it's possible.
Yeah, thank you for the great talk. Yeah, first of all, I was wondering, as your colleague, why you didn't use JetBrains, Aqua, and HTTP client for curl requests. I think it's a little bit more convenient. And regarding the topic, can you maybe share some advices about the best techniques how to build test cases for performance tests?
Okay. First one. I worked with these tools before I joined JetBrains, so I just showed a real experience. And another point is everybody has a curl installed, or at least it's very easy to install in any operating system, but not everybody has JetBrains tools. So I was wondering whether maybe use Postman for Showcase, because most of us use Postman and can install it. But yeah, I decided to go on with something really simple. I hope it was simple enough. But it's a good one. If I do it now, I will use JetBrains tools for sure. And about the test cases, yeah, it's really cool one. So I will tell how we did it in my project before. So what we did a migration of old API to new API, and we were wondering whether it will catch all the users that we were able to catch before. So we went through existing graph, found a few hours of where the most of users come to our app, and we saw how much requests per second we have, what the percentage of usage for every endpoint, and that's where we knew where to get the scenario that we need to reproduce via performance tests. So we need to make, for example, one login, but for each one login, user makes another 20 or 40 requests to some particular endpoints. And because it's JavaScript, it's, quite easy to implement it. In the cases where you don't have a product that you are migrating, but you have a new one, it's always a talk with the business, with product owners, product managers, and other team members about what do you expect, how many users do you expect, because it's not only about verifying whether you can catch the desired amount of users, but also do you have a good enough setup of your hardware. Maybe you use extra machines that are not needed. Maybe you have a little app and you will have 100 users per second max, but you're using, I don't know, infrastructure that costs millions per month. So it's all about finding a right balance in your infrastructure and the code together. Did I answer your question?
Yeah, thank you so much. Yeah, I would like to also to hear from you in our talk on this topic. I think it's
cool.
Great. Yeah, thank you.
Thanks.
As Aqua being mentioned here, just out of curiosity, what are the chances of JetBrains rolling out any tool specifically targeted for performance testing? Like IDE for performance testing?
I have no ideas, to be honest.
No ideas, okay. Thank you.
Maybe you know?
Not really a question, just a reminder. Please catch with Alexander later. I think we need some time to get a tea, maybe at this point in time. Thanks again, Alexander.
Thank you.
Great. Yeah.